All right, welcome. Thank God it's Friday, TGIF. It is Friday, March the 12th here at Spain Park. Today we're going to be talking about stoichiometry. And so we did the activity yesterday. Stoichiometry is the study of mass relationships. In chemical reactions. Okay? How much of this combines with how much of that? It's the recipe for the chemical reactions. It's what reacts with what. So if I look at the chemical, just the simplest reaction, 2 hydrogen gas plus oxygen gas goes to 2 waters. Okay? What is this telling me when I have this equation? In terms of molecules, let's just say that.
The number needed.
Okay, so how many are going to combine with how many are going to make how many?
4 hydrogens and 2.
No, not 4 hydrogens, because we're not...
2 H2.
2 hydrogen molecules, right? So 2 molecules. It is 4 hydrogens, but it's going to be, they're bonded, 2 of them are bonded together, so we have 2 hydrogen molecules going to combine with 1 O2 molecule to make 2 molecules of water. Right? Now, if I had 200 molecules of H2, how many molecules of oxygen am I going to need? 100, right? And I'm going to make 200. If I have 1 million of these, 1 million oxygens, how many hydrogens am I going to need to react with it? 2 million, and I'm going to make 2 million molecules of water. Because no matter what, I'm going to always have to have that 2-to-1 ratio. Now, in chemistry, the atoms are so small, so we don't do anything in terms of dozens or millions. We do it all in terms of moles. So this tells me that 2 moles will combine with 1 mole to make 2 moles. That's why my balanced equation is telling me the ratio of what needs to combine with what and how much I can expect to make. Now, I can't go and measure a mole. But because, just like we did in the activity, because we knew the mass of an individual marshmallow, and we knew how many were in a bag, 454 grams in a bag, then we could figure out how many marshmallows then were in the bag. Well, I have 2 moles. What does each mole weigh of hydrogen? Well, you go to the red number on the periodic table. Hydrogen is 1.01, but it's H2, so it's 2.02. We're going to do some mental math. 2.02 times 2. 4.04 grams. Combined with 1 mole of O2. Now each oxygen is 16. So 16 times 2 is 32. And that's going to make 2 moles. Water is 18 grams per mole, but we have 2 of them. So it's going to be 36.02 grams of water. We're 36.04 because it's 18.02 times 2. All right, so this is the law of conservation of mass, but notice it's not in a ratio. The ratio of this one is 1 to 8 to 9. Okay, you need 8 times the amount of mass because oxygen molecules are so much bigger than a hydrogen molecule. But in terms of what our balanced equation tells us, it gives us a mole ratio. This is the one that we're going to use the most. The reason why we had to learn how to write equations first is because that's the recipe for how things combine when we start mixing them together and we want to know how much product we're going to get. Okay? It's all based on this balanced equation. So, question. How many grams of oxygen gas can be produced when 2.05 grams of KClO3 decomposes. Does that sound familiar? That's the lab we did. We got the percentage of oxygen. We just saw how much oxygen was given off, and we did a percent. But we can do this. So the first step in solving a stoichiometry problem, there are 4 steps to solve a stoichiometry problem. Step 1, write a balanced equation. Okay, we write a balanced equation. So what's the equation going to be here?
KClO3 yields KCl.
And then the other one, it has to be, what's the question asked for? Oxygen. Okay? Write a balanced equation. I forgot the word equation. So we have to balance this.
Just put 2 and find the first 2 and 3 on the last one.
2, 2, and 3. Okay, so that's step 1. You have to have a balanced equation. Sometimes it's given to you in the problem. Sometimes you have to write it. But you got to have a balanced equation. You can't do stoichiometry. You can't make the cookies if you don't know the recipe. The equation's the recipe. Step 2. Just the facts. Ma'am. Okay, let me explain. Back in the day, when I was your age, they had a TV show called Dragnet. And it was a police show, and they had 2 cops. One was very uptight, and the other one was a little more relaxed. They did a remake of it with Tom Hanks and Jim Belushi. Okay. Anyway, in the old series on TV, these guys would always go to a house where a crime had been committed, and they're usually talking to, the mom of the girlfriend who the boyfriend's the suspect or something. And she would just start rambling. Every show, he would always just say, just the facts, ma'am, just the facts. I don't need to hear all this other stuff. In a lot of our stoichiometry problems, there's going to be a lot of superfluous information, just extra stuff, okay? So we're going to have to wade through and find out what's given, what am I looking for? AKA, what's given, and what am I looking for? So, what am I given in this and what am I looking for? I'm given 2.05 grams, right? And I like to just write it right above whatever it's given. What am I looking for? The amount of O2, grams of O2. And I'm going to go ahead and put the unit because the units are going to be important. So I have to have the KCl in here to write the balanced equation and get it all. But now once I have the balanced equation, I'm only interested in my given and my unknown. Okay? So I'm only worried about this one and this one. So step 3 is determine the mole ratio. And you do this really just in your head. Between the given and the unknown. So what's my ratio of given to unknown?
2.05.
What kind of ratio am I looking for?
Mole ratio.
Mole ratio. What gives us the mole ratio? What gives us the mole ratio? The coefficients, the balanced equation. What's the mole ratio going to be between KClO3 to oxygen? 2 to 3. For every 2 of these, we're going to get 3 of these. Now that doesn't mean we have to have 2 of these. It's just you're always going to get 1.5 times as much oxygen as you moles wise as you do KClO3. Okay? It's a 2 to 3 ratio. So then step 4 is just solve the problem. And we now have everything we need to know, but we're always going to go this route. We're going to take the mass of the given, and we're going to convert that to moles of given. We're going to convert that to moles of unknown, and convert that to mass of unknown. Now, how do we convert mass to moles? What's our conversion factor?
The red number.
Do what?
The red number.
The red number, the molar mass, right? The molecular mass. Okay? So, to go from here to here, we're going to use the molar mass. Now, the molar mass, remember, is grams per mole. So since I'm given mass, grams will want to be going on the bottom, so we're really going to divide by the molar mass. Okay? Now, how do I go from moles back to mass? Over here. And this is molar mass of the given. How do I go from moles of unknown to mass of unknown? Well, how did I go from mass to mole? With what? Molar mass. So how am I going to go from moles to mass? With a molar mass. Okay, it's the conversion factor between mass and mole. But this time it's going to be the molar mass of the unknown. So what's the only step we have left? Moles to moles. This is where we've already known how to do this. This is nothing new, these 2 steps. The only thing we're adding in new is the ratio. So this is going to be your mole ratio. Okay? Sometimes, and it's always going to be the coefficients from the balanced equation. Which I sometimes refer to, I kind of like the way it sounds, the stoichiometric factors. Sounds so much better than coefficients. The stoichiometric factors. And it's always going to be unknown over known. Okay, so now if we want to solve our problem here, okay, we're given to start with the given, the mass of the given, let me do it in purple, or maybe I'll do it in green. 2.05 grams of KClO3. That's over an understood 1. So I need to then multiply this by what? What do we use to multiply? How do we go from grams to mole? How do I go from grams to mole?
Molar mass.
Of
KClO3.
KClO3, okay? So it's going to be 39.08, I think, plus 35.45 plus 16 times 3 is 48. Comes out to 122.6. Potassium is 39.0, 39.1. $35.45, 48.
122.6.
30, so 122.6. Okay? So we're gonna say, where does grams need to go? On the bottom, right? So I'm gonna say 1 mole over 122.55 grams. Now if I was to stop right there, what am I finding? How many moles of KClO3 I have? I don't have to have 2 moles. This is just giving me a ratio in which they're going to combine. It's not telling me how much I have to have, it's the ratio. You can a double recipe, you can triple recipe, you can half a recipe. You just need to know the ratios. So that's how many moles I have, and now I know that there's going to be 3 moles of oxygen for every 2 moles of KClO3. That's going to be that times 1.5. No matter how many moles of this I have, I'm going to have 1.5 times moles of that. But I don't care about moles, I want grams. So how do I go to grams? Molar mass of, notice that moles of KClO3 have canceled, grams have canceled. So if I stop right here, I have moles of oxygen. So how do I go to grams? How many grams?
60.
Well, it's times 2.
So
So 32. Now listen, you already multiplied by 3 here. The molar mass is always the grams per 1 mole. The only time you're going to use the coefficients is in this mole ratio step right here. A lot of kids want to put, multiply 32 times 3 for the molar mass. It's always, molar mass is always grams per 1 mole. You're multiplying by 3 here. Okay? Molar mass is always per 1 mole. So we're going to say moles need to go on the bottom, so we're going to say 32.00 grams over 1 mole. Moles cancel, we're left with grams of O2, which is what the question's asking for. So you stick a fork in it because, well, you're done. So if it's on the top, you multiply. It's on the bottom, you divide. So all of our dimensional analysis that we did at the very beginning of the year is going to come back for us now, big time. 2.05 divided by 122.55 times 3 divided by 2 times 32. On the top, you multiply. On the bottom, you divide. Holy cow. What do we get?
that's what phone calculator, 0.80.
0.80 grams of oxygen. So that's how much, if in our lab, that's about how much oxygen was given off, about 0.8 grams worth of oxygen. If you guys go back and look, which I actually have this lab right here. If you guys look, you'll see that your mass of oxygen driven off was pretty close to 0.8. All right, so on Monday,
It's 0.79.
okay? So on Monday, we're going to come in and we're just going to go through and do more of these practice problems, okay? Figure out how to do these stoichiometry problems. We're going to talk about a limiting reactant and percent yield. Do that on Monday and Tuesday. Thursday will be a practice. Maybe do a lab on Thursday and then test on Friday.